Hi everyone. So today we are going to look at how to model credit risk using the Lwando Jarrow Turn model. This is supposed to be Lwando Jarrow Turn model, right? So first of all, what is this model? So we have different types of model or categories of model. There could be more. So we have the structural model, which looks at the firm structure. We also have the reduced model. So the reduced model look at it looks at credit risk from a statistical point of view. So the Lwando Jarrow Turn model fall under it falls under this one. So the LJT actually, it falls under the reduced form model. And what is this model exactly? So the Lwando Jarrow Turn model is a model that tells you the probability of moving from one creditworthy state to the next. So you are going to have a probability matrix. So you are going to have a probability P of T, a probability matrix P of T. So you would have a probability matrix P of T. And this probability matrix would have entries. Let's say you would have A, your B, your C, your D, your E, your F, your G, your H, your I. Right? So this means that you have states. So you have state 1, you have state 2, you have state 3, you have state 1, 2, or 3. So the A means that you are in state, it means that you are in state A, in state 1, and you remain in state 1. And the B means that you are in state 1, you move to state 2. And the C means that you are in state 1, and then you move to state 3. And the D means that you are in state 2, you move to state A. And then the E means that you are in state 2, you remain in state 2. And the F means that you are in state 2, and then you move to state 3. To state 3. So, and under the credit modeling, right, you would always have that these values here at the end. So this would be your default state. So state 3 is the default state. So your last state, your state N, would be your default. This would be like your default state. So that you would default on your risk. So if that's the case, this is what you would need to do. So it means that and then the other thing that you would need to know is that the transaction rate can be so complicated to write or to look at. So what they would normally give you, they would give you the transaction rate matrix. So this would be the transaction rate matrix. So the transaction rate matrix, it tells you the rate at which you are going to move from one state to the next. So let's say you have your state A, and then you're going to have some values. Let's say your beta, your something. Again, I have no idea. I'll just use D, H, and F. It's fine. So if you have this values over here, so this tells that the rate at which you are you are going to move from one state to the next, right? And then again, as I have already said, this over here is the default state, right? And under down here, you are not going to have entries, because if an asset default, or if a company default, it will remain in the default state, right? And then over here on the diagonal, on the credit on the credit state, your diagonals are going to be negative, because that is the rate at which you are going to stay in that state. So the rate at which you stay in the state is going to be the same as the rate that you are going to move to in other states, right? Including the default state. So now, since we say that most of the time you would be given the transaction rate state, then how do you move from having the transaction rate state to the probability transaction rate matrix? So we need to find the PT. So PT, that is the transition, again, the probability transitions matrix can be found by having E T of A, where T is time, right? And then this can be found, again, this can be hard to find because you are not just going to add the exponent at each entry. So you need to find a way in which you can deal with this, right? So if this is the case, then what you need to do is to find A, is to reduce A into some probability. I'll say M, D, M inverse, right? So you need to find it in this in this state, right? And then if that's the case, what you need to do is to say then that, and then you know that by probability, actually by definition, that E of T of a diagonal matrix would just be the value of the diagonal E, like the value of the diagonal. So 0, E, T, diagonal, let's say diagonal 1, diagonal 2, then you just have the same D, T, 3. So this is how you find the diagonal values, right? So, and then P of T would therefore be equals to M E T of the diagonal M inverse. So this is how you are able to find your value. So when you have your so this is how you how you convert your transition rate to the probability transition matrix. Thank you so much. I hope that the lesson was very helpful for you, and that if you have any questions, you can contact us. We also offer private sessions. We do group sessions. We also have summaries and notes and videos like this one. Most of the videos that we have are unlisted, so it means that only a few people can access them. And if you want to be one of those people that wants to access them, you can contact us or go to our website that is shown above there. Thank you very much. Enjoy the rest of your day.